I'm an engineer, and let's be honest, I took a statistics class because I had to. And one concept that I found particularly difficult was the concept of degrees of freedom, because nobody really could explain it to me in a way that made sense. And more importantly, nobody told me why I should care. So today we're ending that, because it turns out that degrees of freedom, the concept, is actually quite important when it comes to planning and analyzing experiments in the lab. And it's also not so difficult to understand when you think of degrees of freedom like money that you have in the bank. But let's start with the standard explanations. And most that I found online go somewhere like, imagine a bus with 5 seats. At the first station, one person gets in, they can freely choose where to sit. The second person gets in and still has a choice. Also the third and the fourth person have a choice, but not the fifth. They need to take whatever seat is left without having a choice where to sit, because there are only 4 degrees of freedom in this example. Or another way, another explanation goes like, say you have 3 numbers that must sum up to 15. You can pick the first 2 however you like, but the third one, it's locked in. We only have 2 degrees of freedom in this example. I mean, both examples, they do make sense in a way, right? But I'm really missing the practical implication here. Why does degrees of freedom, the concept, how does that affect my practical life? Because it does when you're planning and analyzing experiments. Look at this here. Here I measured the filtration rate for a certain temperature. Now, what does this tell you? Is it good or bad? Is it high or low? Should we run the process at this temperature or maybe at a higher or lower temperature? How accurate or reproducible is your measurement? Well, we don't know. We cannot answer any of these questions because we do not have enough degrees of freedom. You can think of degrees of freedom like money in the bank. And whenever you want to answer a question like how filtration rate depends on temperature or how reproducible a measurement is, it will cost you a certain amount of degrees of freedom. Imagine you're building a model to describe the relationship between temperature and filtration rate. Each data point you collect adds 1 piece of statistical money to your account. These are your total degrees of freedom. With just 1 data point, your total degrees of freedom is 1. And that's not enough to understand any trend. It's just enough to report the value. For anything else, you need to have more money. So let's add a second measurement at a higher temperature. And now we already have 2 degrees of freedom, which is exactly enough to estimate a straight line model. With the first degree of freedom, we pay for the intercept, and with the second degree of freedom, we pay for the slope. Or in other words, we now know how the filtration rate changes with temperature. If we add a third measurement, we can either use that to estimate curvature, but then we have no money left to estimate the uncertainty or reliability of the model. And we need more money, we need another data point to do that. And every additional data point that we have left after creating the model, so the money that is still in the bank then, is called residual degree of freedom. The more residual degrees of freedom you have, the better you can evaluate whether the model actually explains the data or if you're just forcing a trend onto noise. Not having enough residual degrees of freedom is like spending all the money that you have on a very expensive car, leaving you nothing left for the insurance. I mean, it might work out fine, but it doesn't have to. Alright, here's a summary of everything in short. First, degrees of freedom work like money in a bank. You can use it to buy you information about your data. If you're out of money, you're out. You should not spend all your money on parameters, but also save some for insurance to estimate uncertainty. And the more degrees of freedom you have left to estimate uncertainty, the better, more reliable estimates you will get.